In this video, we are going to talk about a z-score. Let's take a look at this example. Who is taller, a man with 73 inches tall or a woman 68 inches tall? The obvious answer that you may see here is that the man is taller because he has 73 inches, and 73 inches is, of course, is bigger than 68 inches. However, men are taller than women on the average. So suppose the question is asking this way: who is taller relative to their gender? A man 63 inches tall or a woman 68 inches tall? Because we are comparing the height relative to their gender, one way to answer this question is with the z-score. So let's see what is the interpretation of the z-score. The z-score of an individual data value tells how many standard deviations that value is from its population mean. So for example, a value of one standard deviation above the mean had a z-score of z plus equal plus 1. So z equal 1 means one standard deviation above the mean. And the value of two standard deviation below the mean had a score of z equal -2. So let's just x be a value from a population with the mean of mu and the standard deviation sigma. Then the z-score is found by getting the value of x, the data value, subtract the mean, and then divide by the standard deviations, sigma. Now let's consider this example. A National Center for Health Statistics study states that the mean height for the adult men in the US is equal to 69.4 inches, with a standard deviation of sigma equal 3.1 inches. The mean height for adult women is mu equals 63.8 inches, with a standard deviation of sigma equal 2.8 inches. Who is taller relative to their gender? A man with 73 inches tall or a woman with 68 inches tall? So we compute the z-score for the man's height and also for the woman's height. So we take x, right? X minus mean divided by the standard deviation. X is the data value. In this case, for the man, it is what? It is 73 because you are looking for this specific data. And we subtract from the mean of the US man 69.4 and then divide by the standard deviation of 3.1 inches. And I get 1.16. And we do the same thing for the z-score for the woman's height. The mean, the data value x, we are looking at 68 minus the mean, which is right here, divided by the standard deviations, and then I get 1.5. So you see that the woman's height had the z-score higher than the z-score of the man. Therefore, the woman is taller relative to the population of the woman's height, right? Because if you have a higher z-score, that means you are more away, you are far away from the mean. So the woman, this person has 68 inches, and her z-score is 1.5. So she is 1.5 standard deviation above the mean. So she's taller to the right. She's taller comparing to her gender. She has a higher z-score. Now let's consider another example about the z-score and the empirical rule. Because the z-score is the number of the standard deviations from the mean, we can easily interpret the z-score for the bell-shaped populations using the empirical rule. So when a population had a histogram that is approximately the bell-shaped, then approximately 68% of the data will have the z-score between -1 and 1. So we say that 68% of the data will be between -1 and 1 for z-score, or one standard deviation above the mean and one standard deviation below the mean. And then approximately 95% of the data will have the z-scores between -2 and 2. And again, almost all, 99.7 or almost all of the data will have the z-score between -3 and 3. So if you are having the z-score between -3 and 3, you almost get everything from the data, because that covers almost everything.